Failure. It's a key part of improvement. Looking at our rockets here, watching them fail, we get a chance to make our next set of flights better. And as we look at these failures, we can tell that we could stand to investigate and improve our rocket's stability. We can improve our understanding of our rocket's stability without burning through our rocket engine budget. We have a pneumatic tube launcher. If we can get a tube to fly straight, getting a rocket to fly straight should be a little bit easier. So let's shoot this imaginary tube around and discuss some concepts. Since our rockets want to get all spinny as they try to swap front and back ends, let's talk about some basics of things that spin. Everything has a balance point. This is where something will balance on your finger. Because this is where the mass of the thing averages out, we call this point the center of mass. If you balance your tube or something like a pencil on your finger and then chuck it spinning through the air, it'll be spinning around its center of mass. If we put a lot of mass on one end of our thing, the center of mass moves towards that heavy stuff. And that means the balance point, that's the point that our rocket rotates around, also moves. Here's something that's heavy on one end. Let's spin and drop it. I've got our spinning pencil next to our spinning lint roller so we can compare how they act. I'll repeat the footage so we can take it in. The pencil is spinning around its middle. It's about as heavy on one end as it is on the other end, so it balances in the middle. The lint roller is heavy only on one end. It's spinning around a point closer to its heavy side because that's where it balances. Our rockets fly through the air. If most of the air is affecting the rocket behind the center of mass, it'll want to keep pointing itself into the direction of the airflow, the relative wind. And we can use stuff like fins or different body designs to move the average air effects, we call this the aerodynamic center, further behind the center of mass, and that makes the rocket even more stable. Our rocket engines, however, are heavy, and that means our center of mass starts closer to the rocket's tail. If our aerodynamic center is ahead of the center of mass, the airflow will destabilize the rocket, and it'll fly all catawampus. Finally, let's talk thrust. The thrust line from our rocket engine has to be pointed at the center of mass. If the rocket engine is on funny or if it bends out of place and the thrust line is not aimed at the center of mass, the rocket will spin out of control like this one or like this one. Anyway, this has been my short blurb on how to get your stuff to fly straighter. Chuck your tubes around with clay or something to mimic the weight of your engine and see how they fly. If they aren't going straight, change something. I'll see you next week.